My name is Shuqi Liao, and I'm a PhD student at Purdue University. Today, I'm excited to present our paper, SeamlessVR, Bridging the Immersive to Non-Immersive Visualization Divide. Consider the scenario of a user sitting at a desk, visualizing a 3D scene immersively using a VR headset. At some point, the user wants to remove the headset and continue working on their computer screen, for example, to take notes. However, the visualization looks quite different now, confusing the user. It's not easy to connect from memory what is now seen on screen to what was last seen in the headset. Our work aims to better connect the immersive 3D visualization in the headset to the conventional non-immersive visualization on screen. We propose seamless VR, a method for a gradual transition from immersive to non-immersive visualization. Here is our method at work. When the user initiates the transition, the virtual environment is scaled, translated, and flattened to align with the 2D screen. This way, what the user last sees in the headset is close to what the user first sees on screen. Here are two images composited to illustrate the alignment. Here is another illustration of the transition. The virtual environment is morphed from left to right to a flat image aligned with the screen. We conducted a control user study. We compared seamless VR to the conventional approach of switching from immersive to non-immersive visualization by simply removing the headsets. Each participant performed 4 tasks. In the first task, the participants had to count stationary objects. The participants will start counting in the headsets and finish counting on screen. Here is the seamless VR condition. The smooth transition should help continue counting on screen without having to start over. In the second task, the participants were shown blue spheres. One of the spheres was highlighted in red. The red highlight disappears. The participant removes the headset and tries to find on screens the sphere that used to be highlighted. Here is the experimental condition. The smooth transition should help keep track of the highlighted sphere. The third task investigates dynamic scenes. The user had to play a shell game. 2 green spheres are hidden under 2 of 5 red shells. The red shells are shuffled. The user removes the headset while the shells are still shuffled. The shells stop, and the user is asked to indicate the 2 shells hiding the spheres. Here is the seamless VR condition. Again, we hypothesize that the smooth transition should help the participant keep track of the two shells hiding the green spheres. The final task is similar to the second task with the blue spheres, but now the participant has to check an elements of a factory virtual environment. Here is the seamless VR condition of the fourth task. Here is time and correctness for the four tasks and two conditions. Seamless VR has significant advantages in terms of time and correctness for text 2. For text 2, the participant has to check the blue spheres from the headset to the screen. In the control condition, the abrupt switch requires that participants connect the two visualizations from memory. This is not easy because of the many similar blue spheres. The correctness for the control condition is only 19%. For seamless VR, the gradual switch makes it easy to keep track of the target sphere. The correctness rate is 77%. Seamless VR also had a significant advantage for task 4, where participants had to track a target factory element across the visualization switch. However, the advantage is smaller than in the case of task 2 with blue spheres. This is because the factory has more visual landmarks that facilitate mapping the two visualizations from memory. Surprisingly, Seamless VR did not have an advantage for text 1 and 3. In text 1, participants has to count objects across the two visualization modalities. We think the lack of Seamless VR advantage is due to the animation introduced by the morph, which makes counting challenging. One of the challenges is to find a morph speed that suits individual participants. The shell game in text 3 was just too simple to differentiate the two methods. This is despite switching from the traditional 3-shell game to a 5-shell game. Participants completed a custom questionnaire. Here are 4 of the questions. Q1 and Q2 are negative questions with their answer flipped in the graph for more to always mean better. Seamless VR had a significant advantage over control for each of the 4 questions. Our Seamless VR prototype is now available on GitHub. Please feel free to explore the repository and share your feedback. Thank you for your attention.